Nice. Thank you. All right. So everyone did very good. I think that was your conclusion for the quiz CP10. So everyone found the home position, almost everyone. So that was good. So things that we wanted absolutely to be correct was the home position and also the expression for forward kinematic. So if you remember, we were using pre-multiplication, right, to find the position, define that t. So m, our home position, is the first configuration we have. Every rotation happens has to go before. So those of you that put m at the beginning, you're wrong. So when you are reading it, t theta equal to, so is your last joins e to the power of bracket s, well, say 6, theta 6 to 1, and then your m. So m is your home position. So that was one thing.
I think even more than that, it was like in my mind, just working out the whole problem. It takes a long time, and just forgetting to write m at the very end. Like,
Yeah. Yeah, also you have to write that. So m is basically like no rotation, right? So it's like times 0. So don't forget that. Then for screw axis, so this I have talked to some student, I've seen it. In my solution, I specifically mentioned, so if in the exam you make a mistake, I've already told you so you're gonna lose point. Screw axis SI is a 6x1 vector. There are two things in there, omega I and VI, the angular velocity and linear velocity, right? That we found through that table. So you grab those points and plug in there. So you're introducing 6 screw axes to us. Now, when you are trying to calculate the expression for forward kinematic, you have to say e to the power of bracket S1, theta 1. So now that bracket S has a different formula that we expand, right? We use omega I and VI in it. Omega I is not directly used, is the matrix representation of it, which is through skew symmetric representation. Thank you. But omega 1, omega 2, omega 3 comes from that. You plug it in and you get the value. VI is just VI vector, right? And we appended by 0. I think I kind of misleaded you on that one. So because both of them are vectors, so we append those with zeros. For m, which is a position, has a rotation and position, the position is appended by 1. So I definitely mislead Parth because I wanted him to lose points. But so you calculate bracket S1, bracket S2, bracket S3, 4, 5. So this has to be written. Then for the final expression, you can just leave it as exponential, right? That will be acceptable. So these were the point that you saw. You shouldn't have lost point if you made a mistake in calculating cross product or something because of time and stress and nobody was waiting for a quiz. So I understand that, so you didn't lose point for that. But in the exam, if you are asked to calculate cross product, you bring the equation with you and you do that every single time, right?
There was a couple of cases where I wasn't too harsh on it, but I didn't take off points if it was calculated incorrectly, but if it wasn't attempted at all.
Yeah, no attempt. It's like I don't give a rat about you. We won't give any point to you. So just like a two-way. So you have to show you understand. It's just either the pressure of time or you just made a mistake that you don't deduct point. Anytime you're grading, you look at your thought process, like how much you know and how much you put. Then if you lost points that you think is not fair, talk to him, and then you can get those points back. But I trust that Brett is always like pretty precise and nicer than me when he's grading. In the exam, I'm gonna share that with Zoom. So I posted I don't know if you looked at it or not. Exam practice. Here, exam 1 review. I put all the questions in there. So you'll see that the first part, which is the conceptual question, I just wrote, there will be a question about this. I didn't write the question. But the problems, I wrote an example. So you know that, for example, there's going to be, like here, there's going to be something about degree of freedom system, right? There's going to be something about transformation. matrix. There's gonna be something about screw axes and POE method. But the question obviously is not gonna be this, right? But I've changed the example, but it will be a question about this topic. So you kind of, when you're studying, you know. So my suggestion is before Friday, if you could like spend maybe 10 minutes, just go over. And in your mind, like, how would I approach this question? If you do that is enough. On Friday, I'm going to show you the solution and I will tell you how would I approach this. In the exam, if you are at some point that you're like, am I running out of time? I don't know how to do this. I can explain, but I don't know like one part. In English, write for me your thought process. You will get some point for that. I really care about your thought process if you know the process of something. You might not have brought some equation and you cannot go further, right? But you know how you should do it. Include all of that. If you already know everything, just solve and you're done. Sounds good? You have to show all of your work. Just writing a final solution does not get you any points. All right. So this is out of the way. Let's get to lecture today. Yeah, I think I talked about everything. I posted CP10 also. All right, so we're going to solve a couple of examples of DH convention. So one thing, when we used POE method, we calculated every frame with respect to the base frame, right? In DH convention, we are finding the transformation between frame I-1 and I. And as we go forward, we are finding the relationship between two adjacent frames. When we multiply, then we find the relationship between base frame and end effector, right? So that's the idea behind this. This is the big matrix. So once you find all of those DH parameters, theta I, now we don't know what these are. Alpha I, AI minus I, and DI. Once you found that from table, for every single transformation from one frame to another, you create this big matrix. So at the end, you'll have four or five of them multiplied by each other to find your final configuration. So we didn't talk about how to assign joint. We will do it today. The example I gave you had all the axes, how to assign joint axes. So we know how to assign joint axes, but how about the other two? I didn't discuss it. For this example I'm going to solve, you also have the all the axes. In the second example of today, we are going to learn how to assign those. But we know what is joint axis. Do you remember? So if you have a rotation, a revolute joint, the axis that revolute is happening about is your z-axis of that frame. So we are going to identify all the z-axis first. Then assigning reference frame, we didn't go over that yet, but say that you have the frame, you assigned it, find DH parameters. That four expression I gave you, you follow those one by one to find these. Then find end effector configuration. Now, let's go. Before I go to the example, I want to tell you why we get the ground frame and end effector frame where we get them. So if you notice, we will also always put the end effector frame on the last existing frame, right? You can, because these are all convention, you can say, you know what, I want to get my end effector 10 meters from here with some rotation. You could do it, you just have to consider that rotation and distance. To make our life easy, we put that frame on where your last frame is, somewhere close to that. For ground frame, also, we will try to put it where the first frame is, for the first joint. So those like skinny lines or dashed lines, that shows that these are on top of each other. So that's a convention just to make our life easier. There will be less calculation. They will create a lot of zeros in your table. The more zeros, the better. Sign of 0 is 0, 0 but multiplied by something is 0. So your matrices will look a lot simpler. All right. Now we can. So if you choose ground frame to coincide with frame 1, our first frame, we basically are creating a 0 to be 0 and alpha 0 to be 0 and d be 0 because they're all on top of each other. There is no twist, there is no offset, right? There's no distance, there's no link there. So we give all of those 0, we only have our variable. So, and same for end effector. So this will become something like this. So now this is ground frame. So if you have your ground frame, so either have a revolute joint or prismatic joint, right? You only have two kinds of joints. In case of revolute, let's say frame 0 is ground, frame 1 is your joint. At the beginning of the time, they are on top of each other, right? When time starts, the revolute joint will start rotating, so you can see theta, where theta went. So ground is connected to the ground, so it's fixed, right? Now you see that they are coincide, so there is no offset, there's no twist between them. The only thing that changes is your theta. So this theta is basically, so this is theta at time 0, right? At the beginning of time, these two frames are the same. Once the rotation happens, then you have theta star. So then theta star, here, basically this is your theta star, this is the joint variable. Everything else is the same. If you create the link for that, like link, if you are gonna write link I, did I call it link I? Let me check, yeah. So link I, so A I minus 1, alpha I minus 1, D I, theta I. All of these will get 0, this will be theta 1 star. It just makes your life easier. That's why we put it there. Same for, so now if it was prismatic, now what would be the table for prismatic if we were going to create that? So let's say our first joint is prismatic instead of revolute. So this is link 1, link I, so I is 1, alpha I minus 1, A I minus 1, D I, theta I. So this is 0, no twist. So at time 0, they were on top of each other, right? And then DI, what is DI here? DI star, D1 star, because it's our joint variable. There is no theta offset between them. So theta becomes 0. So you'll see that this is a lot easier. We could put our frame somewhere that makes our life hard and put all the numbers based on DH convention, your final solution would have been correct. So assigning frame is very important. Your final solution is right, but you just gave yourself a hard time to calculate things, all right? Now, same for end effector. You could assume end effector farther from your frame, or you could put it on top of your frame at the beginning of time before any rotation or translation happens, right? So same thing for this. You will just have easier time when you create your table. All right. Yeah, let's work on this example. We already found the forward kinematic expression for this robot from exponential POE, right? If you remember, we already have that. So if we simulate that and plot the simulation from POE and we do it from DH table, they should look like the same. They should end up in the same position. All right, but let's create the DH table for this. So what's the first step? Assign joint axis. So if we already have all the frames, right? So we kind of know all these, but I'm gonna just emphasize and show it. So this is the Z1 axis, this is Z2 axis, and this is Z3. It's already shown in the next example. We're going to learn how we can create X axis now, but we go to the next step. We already have the frames. Next step is create the parameters. So create the table. How many links you have in your table? If we are going to create a table for this. 3. Link I, 1, 2, 3, because I have 3 joints, right? So let's call this AI minus 1, alpha I minus 1. I probably should use a smaller because I'm going to use a lot of real estate here. DI and theta I. Okay, so let's just start from link 1. So we will see that our ground frame and first frame are on top of each other at the beginning of time. For end effector, it doesn't show. I'm going to assume this is going to be my B frame or end effector frame also, right? It's just an assumption, yes.
So that left column is like length and technically in this, I think it's 5 lengths.
So link I is the joints. So when we say link here, I'm just, so these are basically just those joints. Every joint connects two links. So link I is basically because of joint I. You can just put I if it confuses you here. Just joints. From 1 to 3. All right. If you're following your book, it says link I, so that's the same thing. All right. For the first one, what is I minus 1, which is A0? What is A0? What was A0? Distance of Z0 and Z1 along X0. 0. We put them on top of each other, so the first 3 are 0, right? So just go ahead and put all 3 of them 0. So these 2 are 0. Now, in 3, what is theta I? This is the easy one, right? Because we set it up for ourselves. So theta 1 star. So that's taking care of the first one. Now let's look at the second one. So alpha 1 here, alpha 1, sorry, A1, what is A1? A1 is distance of Z1 and Z2. Remember, I is 2, right? Along X1. So this is Z1, this is Z2, and this is X1. What's the distance between, what's the mutual perpendicular between Z1 and Z2 along X1? L1, right? So this is the distance. Looks like this. So this is going to be L1. What is alpha I minus 1? So let's see what is that. So which is alpha 1. Alpha I minus 1 is the angle of Z1, Z2 about X1. Let's draw this one, all right? Let's see what's going on. So I'm gonna draw Z1, and then this is Z2, so this is in 3D. And then this is X1, right? Does everybody see that? So all I did, I grabbed Z1 and Z2 and X1 just outside so I can see the rotation. All right. So what would be the number? So what? Yes, 90 degrees, right? So this, the direction here is important. You're still following right-hand rule. So you're rotating from Z1 to Z2. So the rotation is happening in this direction along X1. So it's a positive rotation, 90 degrees, or pi over 2. Correct? Yes. Okay, good. Now, distance I. What's distance? What's D2? Distance, I'm going to just write it also, just to help you to follow me while you're writing. D2 is distance between X1, X2, and along Z2. Z2. So this is X1, this is X2. I'm gonna draw it outside. So this is X1, right? This is X2. Agree? I just grabbed it out. And then we want to find it along Z2. This is your Z2. They are coinciding along that, right? What's the distance? 0. So looking at it, it's like, oh, there's a distance in this direction, but we don't care. We care about the distance along the specific axes. So that is 0. So they are touching each other. Ooh, so that would be 0. Now, what is theta I? here. So this is the special case that I told you about before. So let's create that. So theta 2 is angle between x1, x2 about z2. So this is x1. This is x2. And this is our z2. Now we want to find the twist, right? So I'm just gonna move this guy here. Just show this is z x1, right? It's the same. I just moved it, I continue. Now, if you see, so the rotation is going to happen around z2, but there is currently an offset between these two frames, right? By 90 degrees. Now, if we rotate, so x2, so x1 came to x2, but in this frame, what is the direction of motion? Like counterclockwise, right? So you're basically moving this way whenever the rotation happens, right? So that pi over 2 minus theta star, wow, this was loud, sorry. So minus theta star, it means that there was some fixed angle, okay? But as you start rotating, that angle gonna decrease, and then at some point it's gonna be 0 and then goes around. So we are going to count for that. So it's pi over 2 minus theta star 2. Then that is the pi over 2 angle that we currently had. And we know the rotation about z-axis is going to be counterclockwise. It's been given to us and is always following the right-hand rule. Yes.
Are we going from 2 to 1 then?
So no, the rotation happens about z2. That's what we
Yeah,
care.
we're going from 1 to 2.
So 1 is our previous frame, right? What's that?
So wouldn't that be negative pi over 2 then?
No. So this is the existing angle between x1 and x2, right? So if you start rotating this joint, which way this joint is moving? So it's moving like that, right? So now if you start, because this is what is moving, this plane is going to move because of that, right? So if you start moving, this x2 is going to go this way. X2 is going to go toward x1 because that's your second frame. The motion is because of the second joint's motion.
Okay, so there's 2 moving.
So because of the rotation of Z2, 2 is going toward 1, right? So we don't say that, oh, we have x1 is the previous frame, you have to see where x1 is going. No. Z2 here is one that is moving because we are finding the configuration because of second joint, right? So this is the effect of second joint. So what you will do is once you have this, I will always draw, then show where your frame is and simply just rotate. And then this is rotating that way. Yes.
Why isn't it private? Or why isn't it theta
What does theta minus pi over 2 mean?
It would just be like your offset.
So if you have a 90-degree angle, theta, this is 90. So this is 90, right? So theta, so you say it has to be pi over 2. No, you say 90. You say theta minus pi over 2. Okay. So what does that mean in when you're drawing it? Where is a negative pi over 2? So the rotation, the positive rotation is this way, right? So this is a positive pi over 2. Here, the positive direction of rotation is this way. So you have the angle between the two is pi over 2, just the value, right? What is happening during the rotation is that if I rotate this, I'm gonna use the blue to show you what's gonna happen. Because x2 is connected to z2, right? They move together. If some theta star happens, this is gonna be your new x2. right? There's gonna be theta star. Then it's gonna go to 90 degree at some time. Then gonna go this way. So it's gonna surpass that 90 degree. So starting from 0, currently at 0, there's negative pi over 2 between x2 and x1. Then as time goes, you're covering that 90 degree and then you surpass that 90 degree. So the direction is because of z, the positive direction of your z2.
So that line is on where you were when you started.
Yes, exactly. Yes. So it's always like that. Every joint that everything we are analyzing is like where you are with respect to your home position of that. So remember, we are only looking at 2 frames with respect to each other, where they are with respect to each other, right? What's your question?
Couldn't we also, wouldn't it be equally correct though to say that it starts at negative pi over 2, and then as it goes over x1, then it starts to
From 0, yeah, that's the same thing, yeah. So you have a negative pi over 2
that'd be
between
like-
them, there's a twist between them.
That'd be like theta star minus pi over 2.
No, theta 2 minus pi over 2, no. Oh, what did the, you didn't see this. Why are you talking nonsense, everyone? I'm sorry, Cam. You're probably trying to tell me this. Don't talk nonsense, I wrote it correctly. Make sense now? Sorry, I didn't look at what I wrote. It's obviously, because at theta star equal to pi over 2 has to be 0. Sorry, brain fart.
Okay, wait, so now, when I asked,
You still, when you move 90 degrees, this goes here. So the angle between them is 0 now. All right, let's do one more and see if you still have problem. Okay, let's do the next one, finish this, and then we go back to it. All right, how about the third one? The third joint. What is AI minus 1? So basically, what is A2? L2. Agreed? Because L2, A2 is Z2 and Z1, Z3, right? Along X2. So Z2 and Z3 along X2, and X2 is in this direction, so this distance is L2. I'm not gonna write out all of those. I will actually write the important ones, but this one is simple. How about alpha I minus 1? We're gonna have some discussion here. So negative pi over 2, correct. All right, bless you. Okay, so I'm gonna just show that for I3, I'm gonna show alpha 2. So alpha 2 is Z2 and Z3 about X2, right? So Z2 is in this direction. And then Z3, this is Z3, but the important aspect is X2. Right? And if X2 is in this direction, this is the direction of rotation, right? So Z2 went to Z3. This is 3D, this looks like 180, it is 90 degree. Can everyone see this is 90 degree? Between them, these are perpendicular. So around this either is 270 or negative 90 degrees. What is DI? So DI is, or D3, distance between X2 and X3, X2 and X3, X3, these two about along Z3. This is Z3, X2 and X3 are in the same direction, right? Distance is 0, there's no distance. There's no offset, basically. They're going around this along the same point. Now, what is theta I? So theta I is angle X2 and X3, X2 and X3 about ZI, Z3. So there is no current offset between them, right? So theta is R, theta star is, so you can write theta 3 star. Now, this is just the DH parameters. What is the next step? Sorry. if we were going to find the expression for forward kinematic.
We'd have to make all the matrices.
Right, so let's just write it in form of a matrix that we know we're gonna use big matrix, right? So T or T0 to 3 is T0 to 1, T1 to 2, T2 to 3. To create each one of these, you have to go to the table, grab those DH parameter, go to big matrix, plug them in, and you do the multiplication, you get your solution. Again, here you see that you have some constant values you get from the user, or you know the configuration of the robot you plug in, and these are functions of time. So you can say that, okay, we're gonna go to 30 degrees. When you're plotting it, you're gonna show the simulation, start from 0, create line space, 1 degree at a time, and you see that they're gonna rotate, and then the next turn is gonna rotate, and you'll find your final degree if you're going to simulate. Make sense? Now, what time? All right, we have time. Let's go back to this and make sure everybody's clear about this. Was there a question? I think you had a question? No? All right. So I usually draw this. I always have that handy. I forget it if it's the semester I'm not teaching, then the semester I'm teaching, I'll just review and put it somewhere. So keep it handy. There are a couple of equations by now, you know you need it all the time. So put it somewhere in your notes and you'll use them. Now, frame attachment. We skipped this part because I wanted you to understand how the method works before we get here, okay? Questions? No? All right, so we know that we will assign the z-axis, right? That's the axis of rotation or axis of translation. So we are gonna find all of those. So this is, if I'm not wrong, this is z, let's say I-1, this is zi, okay? We find the normal, common normal between the two z-axes that are adjacent from one frame and another frame. So here is the common normal. I'm gonna use another color. This is the common normal between these two because it's perpendicular to both of them, right? Find those, then place the origin when. So for frames, so we will place the frame for zi minus 1 first, and then we move to the other one. So when you find the common normal, wherever this coincides, you place the origin there. So that will be the base of your frame, the origin of your frame. All right. Now, so this is the axis, the I-1. This common normal will be your x-axis, xi-1. Then for y, you just follow the right-hand rule, right? Really, we don't care about y-axis because these two are important. We find twist from x, right? And then we find the joint variable from z. Now, move to the next one, next frame. So next frame is zi, and then this one is zi minus I plus 1, let's say. The common normal is this. Place the origin, we'll call this xi. Moving to the next frame. Oh, look at this, funny. The I plus 2. Zi and z2 are coinciding. Which way is the common normal? So if two axes are crossing each other, they're creating a plane, right? How do we find their common normal or the vector that is normal to this plane? How many solutions do we have? Let's say 2. Because you can draw a perpendicular axis in this direction, you can draw one in that direction. They're both. So if this was the plane, where's your plane? So that's solution, right? I can say this is perpendicular. You could say, no, this is perpendicular. I say both of them are. This is the case that you can get the direction of X in either one of those directions. And as soon as you hear that, you'll say, oh, but my table is gonna be different from Alex's table. It's like, fine, he will follow his frame assignment. And you'll follow yours. From here, you're diverging. It's totally okay, because after you multiply all, you will get the correct solution both of you. So here is one case that you might say, hey, this is my xi minus 1 or xi minus 1 plus 1 prime. Either way is fine, okay? You'll grow some intuition which direction is easier, because you're thinking, you're gonna look at your next one, next axis, say, I want alpha I to be 0 probably, right? So you're gonna get in the direction that will make alpha I 0, just for sake of like less calculation, but you grow those intuition. But the beginning is fine either way. Make sense? So that is the other special case that would happen. Other than this, you can always find the perpendicular and then find the extraction in that. And you go until you run out of frames. You keep going until you're done. So that is the step that we skip, because I have given you all the axes. Now, the thing is that when you go online, I'll give you assignments, and the first thing you do is like, let me Google online, see if this I can find this solution, because you're students, you don't have time for this. And then you find it, it's like, great, and I'm gonna tell you, I'm gonna teach you variables, and then cool. But the thing is, every other solution out there is using a different method of assigning frames. And then by the time I look at it, I know that you cheated. Not cheated, but you had help, okay? So there are two ways of doing this, assigning frames. So if you're checking online for confirming your solutions, just make sure it's following what you're following. Yeah, that's right. This is, I'm following your book because I want you to have a couple of extra examples to review, right? The traditional way is the other way, but it doesn't matter. At the end of the day, they're both gonna give you the same solution. I thought you will benefit from a couple of extra examples. I can see of your book. So the example we saw for POE have counterpart of the pH table in appendix C. So you can always compare them. Okay. All right, cool. We are for once probably on time. So this is an example. So this is a robot I just draw. Let's say, okay, you're hired, you've been hired this week. You found a company, it works with robotics, they hired you, said, hey, let's just show me what you know. And they show you a robot in their office. Say, can you find a forward kinematic for this? The first thing you do is say, okay, this is an actual thing. I'm gonna draw a diagram. Okay, a diagram. There's no frame attachment or anything. You have to find those all by yourself, right? So this is the problem from the beginning. So you find that, and why are you interested in forward kinematic? Because they're gonna say what the end effector will be if this is a good example of industrial robot. If this was motorized and I wanted to go to home position or some program position, it will rotate, doesn't rotate. Someone rotated this is awful. So let's say you wanted to be here, you knew exactly the angles, right? You're programming the angles and it goes here. That's a position you usually use. There's another, like, there are 3 positions you're going to use for this. You're going to program all of those, but then you need to know what thetas are to send it to that position, right? So that's why you use forward kinematic. So you need to look at this, draw the diagram, assign the frames, then the rest of it should be easy because we just practice, right? So this is fairly easier because they're all revolute join, all in the same plane. So all the z-axes are parallel. Finding the table is a lot easier. But let's do that. Let's find all the z-axes. First of all, how many joints do you have? 3. So this is a 3R manipulator, right? Do you remember how many degree of freedom this has? Quickly. Open chain mechanism of NR. How many degree of freedom? 3. So N. So if you had an open chain mechanism like this, NR, degree of freedom is N. So So I know this is pretty good freedom. So I have theta 1, theta 2, theta 3. So here is theta 1, theta 2, theta 3 again. This is just shown, this is not in home position. Home position probably is either like this position or standing position, right? You will have some value. So you're basically starting from here. The theta is just showing you the direction they will rotate, right? So these are Z1 out of the plane, Z2 out of the plane, Z3 out of the plane, correct? Now find x-axis. I want everyone to try to find x-axis, then create the DH table. This will be your last class assignment. Your CV11 is going to be this. You're going to have time until next class to work on this. I'll start the class with this one, then I review the examples. This one, you will have more numbers in your table, just to give you an idea. This distance is E1. There's a fixed distance D1 between frame 0 and frame 1. But for now, do this. I'm gonna walk around to see what you're doing. So assign the frames. Assign the frames. Find DH parameter, that's all. You have to use your knowledge from previous slides. Yes. The x-axis. Yeah, I didn't give you the frames.
So the previous
Your assignment.
example that we saw
Yeah, you know, like, okay.
had the angle that's coming off of in line with the previous point. And this one you're having a position. I'm wondering if that's standard.
No, I just wrote it like that. That's usually like this. Because you want to
Okay,
see
so
where
it's
you
not
go
from-
with respect to your previous frame, right? Yeah. Don't do that to me. This just makes me want to grade your paper really difficult. Like, no mercy for Michael. You see what I'm dealing with? Today has been a very stressful day. Thank you. It was stressful, but I'm going with, I'm grading. I'm just a nice grader, but I just talk about it if you want to look and fix it. You're done? You were already trying to, I had a question. There's math. There was another question. Okay, we're not gonna come back to this for a while, so hopefully everyone will be able to follow. If you're watching Zoom, we are just working on this assignment, so. That all of those are positive in that direction. So the thing is, okay, let me explain this, because I think I explained it before and there was some confusion. All right, everybody pay attention, stop working what you're working on. So, this also relates to, past participation number 8. Which one was I asked about moving reference frames and, okay, I think it was 8, no, 7, probably, okay, one of those. So, some of you might not have had the correct answer for the quiz and you thought that, oh, I thought the moving body has a moving reference frame, right? Do you remember that question?